All right, another example where they say to determine whether the graph is symmetric with respect to the y-axis, x-axis, or origin. Okay, so here is the equation we're going to be applying our test for symmetry to. First of all, let's see if this thing is symmetric about the y-axis by replacing x with a negative x. So this will look like y to the fourth equals 2 plus a negative x squared. All right, so the thing in question here is to figure out what does that negative x squared do? Well, you know, anytime you have a negative quantity and you multiply it by itself an even number of times, you're going to end up with a positive x squared. Okay? So this is y to the fourth equals 2 plus a negative x squared is the same thing as just x squared. All right? So this is exactly what we have in the box above. It's agreeing in sign and everything. So, hey, this thing is going to be symmetric about the y-axis. So can't we just say it's not symmetric about the x-axis nor the origin? Well, no, you can't, okay? Now let's go and let's check to see if this thing is symmetric about the x-axis. Remember, to accomplish that, we replace the y with a negative y. So this will look like negative y to the fourth equals 2 plus x squared. Now, negative y to the fourth, because this is an even exponent here, is going to mean that's going to be the same thing as just a positive y to the fourth. And again, you can write that out if you want. Negative y times negative y times negative y times negative y is negative y raised to the fourth power. Now, when you multiply these negative things by themselves an even number of times, that's going to mean that's going to be positive, that's going to be positive, okay? So that's going to give you the positive y to the fourth. That's how we got that. Bring down the rest of it, and you'll see our equation is exactly what we have in the box above. So this thing is also symmetric about the x-axis. That could happen. All right. Now let's see if this graph is going to display symmetry about the origin as well. Okay. We're going to replace both y with a negative y and our x with a negative x. That's where we replace both. And we just saw over here in purple how negative y to the fourth is the same thing as just y to the fourth. And over there in blue, we saw how negative x squared is the same thing as x squared. So you know what? This equation, if we were to graph it, displays all three types of symmetry. Now, I was kind of curious what y to the fourth equals 2 plus x squared looks like. And so I pulled up Desmos, and I put that in to Desmos, and there's the graph of y to the fourth equals 2 plus x squared. You see the symmetry about the y-axis, okay? You see the symmetry about the x-axis. And you also see the symmetry about the origin, okay? Now, for symmetry about the y-axis, we want to see if this point at 5, whatever it is, okay, I think that might look like it is at 2. I don't know. I don't really even know if it is. Let's see. When x is 5, I don't know. We're just going to say 5, comma, whatever that is. Okay? That's going to be the same thing as negative 5, comma, same thing right there for the question mark. That means that this thing is going to be symmetric about the y-axis. Okay? To see if this thing is symmetric about the x-axis, if this is at 5 question mark right here, then the graph would also contain the point 5 negative whatever that was there. Okay? Now to see if this graph is going to be symmetric about the origin, If the graph goes through 5 question mark here, this is for the origin, then it also needs to go through -5, negative question mark, right down here. So -5, negative, whatever that number is, there. Okay? So that's kind of how we can also verify, given a graph, if we have symmetry about the origin. And we will see that on these next examples.